Yes, yes. So, and visualize and see if you have any questions. So before the step, you try. Sure, I'm coming. So, repeat to the office. You went to cook it. I think you need to you went to get lunch. Hello, Bernard.
Hello.
Yes, I think we can start now. We can
Okay.
go. Yeah.
Okay. Okay. So at the end of this morning, well, during this morning we have seen how to deploy, I mean, on the theoretical side, an HPC cluster. Okay. Today afternoon is to practice that. Okay, using the link on the screen right now. So, as I understood, you are not able, and that's well, that's expected because it needs a huge infrastructure. On the I forgot to explain that in the detail, but well, what I think we can do if everyone is okay. For what I understand, you all share the same private network. So what could be interesting is that if everyone is okay with that, each user here, I will increase. Here we have some IP network. Okay. What we can do is that each user take a number. So you exchange between you, and each one of you take a number and increment it here. So user 1 will have 10, 11, 0, 1, etc. So you just increment everyone an IP. So at least you can share the same network, physical network, without interacting with each other because you will all work in a different subnet. I think it could be a good move if you think that's okay.
Okay. We are taking note of that, and when Bola comes, I will inform him of that.
Okay, okay. But at least you can start the whole first part without needing anything. I mean, you can start doing the Odin installation. Okay, you can start the whole practical session, but just do not enable the DHCP server here. Okay, you see these lines? Don't do them. Don't execute these two lines. You can proceed with everything else, but don't proceed with these two lines because there will conflict on the network. Once Bola is here, we can discuss how to manage this part. Okay. Also, what I can propose you, since you will not be able to do the PXE yourself, what I can propose you is that once you have a rich, where is it? Where is it? You do this, blah blah blah. Okay. One, you have reached the other node installation, the boot over PXE. I will do a demo on my side with my VM. I will show you how it works exactly. I mean, what you have done, how it boots, what's happening in the log file, etc., etc. So we can interactively discuss about that because I think PXE process is one of the most important parts of the job, in fact. Okay, so you can do the training right now and do not hesitate to ask for any question. Do you all have access to the VM?
Yes, we have access. We all shared the account yesterday.
Okay, that's cool. One last tip. Um, Where is it? Oh, I forgot to push it. Oh, bad luck. Where is it? Yeah, okay. Just here, you have the ISO available. I know Bola provided the ISO of CentOS, everything inside your root directory. To save space inside your VM, you can just, instead of doing all of this, okay, you can just directly mount the ISO into this folder. Okay, so let's edit that directly. It will be easier. Okay, so I will just update right now. It was not
You can
taken.
also remove the command for starting the DHCP server.
Yeah, I will do that. Give me a few seconds. Why is it not working? I don't see the numbers. Okay, I forgot to refresh the page. Okay, that's all. So I wrote, you have 3 ways to mount it. Use way number 2 to mount the repositories. Okay, here. Simply mount the ISO directly to the good folder. Okay, don't do way 1 or
Hello, Bernard.
Hello.
Yeah, sorry for joining late. I had an emergency call.
Don't worry, don't worry. And I will command the. Well, we were speaking about how to do the training with shared network, and I suggested that each user take a number, each one a number, and increment the second number for its IP. So for example, user 1 will use 10, 11, etc., etc. So everyone can share the same private network. If that's okay for you. I will also command the DHCP part for you. Where is it? Here it is. You have to refresh the page to take into account the change. Also, during the launch, I added the GPU part, the NVIDIA part. So now at the end, you have the GPU part available.
Hello, Bernard.
Hello.
Yeah, please, I just want to make a suggestion, please. I don't know if that would be fine by you. Uh, Being that the participants are still on campus and then they will be here all through the weekend so that they can use the weekend to practice quite a number of things and they have good knowledge of the hands-on. I want to suggest I give you access to the virtual machine we have created, and then probably we do a little brush up on that, on how to go about this setup so that they will have a better understanding. Then after today, after they might have left there, they watch everything you are doing with the manual, and then leaving here today, you have just like 2 hours to spend today. They will be able to go back to their respective hosts there and connect to the server remotely and carry on their hands-on using the manual.
Okay, no problem.
Will that be
But if
fine?
I
Okay.
already I have my VM here. If you want, I can use them to show you everything.
Okay.
If that's okay for you.
Okay. You want to use your VM?
I think it will be faster because it allows me to share also the console, everything. If it's okay for you. If you prefer, I can use your VM. It's okay for me. I don't care, honestly.
I would prefer you use VM so that peradventure, if there are any issues,
Okay.
because during the weekend we might not all be together.
Yeah, okay. No problem. I understand. Then
Yeah.
please send me a way to connect to the VM.
Okay, I will do that now.
Mhm. Can you add those two options? Okay, yes. Okay, let me edit again. No problem. I have seen the message. I will update it.
Hello, Mr. Level.
Hello. Oh, don't call me Mr. Leveg. I'm not that old.
You are not Mr. Level.
Benoit is okay.
Yeah. Um, how we do with the installation of CentOS? We installate it separately, or we are waiting for you for the image, for the deco image, or not?
It should already be installed in the VM, if I understood. In the management VM, it should be already installed, right?
I don't
Bola?
understand.
I mean, you were given 3 VM, and for what I understand, the first VM is already deployed with an operating system, the CentOS.
Yeah,
So
that's
you,
the head node.
yes,
It's
you
already
don't have
deployed. So you
on
now
the
have
other,
two
um,
additional.
yeah, you have to deploy the other node using PXE.
Yeah, they
You
are
see what?
deployed to use Pixie.
Yes. So the first node should be already installed.
Yes. Yes.
Well, what I can do also, if you want, for after this um, training, I can send you a small how to set up on your laptop a few VM later if you want to continue to practice. I don't know, Bola, if you will let users use the VM after the training or not.
I think
So,
that will be fine.
okay,
That will be fine. Yeah.
okay.
So should we go? We should continue.
Yeah, please, can you send me the link?
Okay. I'll send it to your mail right away.
Yeah, thanks a lot. What I will do also is to, well, send at the end, okay. Well, some of you this morning were asking about InfiniBand. Have a look at to this, please. It's a picture of the background of the cluster we have in Bretagne, in France. This is a storage system, okay? And in the middle here, you have two servers, okay, that are used to export the storage available in the big storage B, okay? You have the SAS cable everywhere here. You can see here the big hole here on this one and same above. These are InfiniBand connection. So you have the Ethernet one here, okay, the BMC here, and here you have the InfiniBand. It's not connected right now, but you have the InfiniBand connection. Okay, so this is InfiniBand. It's a different kind of shape to be plugged, so you cannot miss it. Okay, let's try. Yes.
Yeah, Bennett.
Yeah.
Yeah. Yeah,
Very
please,
interesting.
can you send me your public IP so I can allow you to SSH into the server
Oh,
from the firewall?
okay, I understand. Let me connect to my because I don't have a static IP here, but on my own server I have one. Give me a few seconds, please.
Okay. Or the one your NAT is behind.
No, it's okay. It's okay. Give me a few seconds. It's one. I will send it to you by mail right now.
Okay.
Send.
Bernard,
Yes.
so can I explain to you what we have there? Or you already understand what we...
Yes, it would be nice if you can explain a bit. I think I understand a few things, but it's better if
Okay.
you explain me
Can you click on the Kubri?
here.
Yes. The drop down. Yes, this is what we have for all. You can see 100 is... So
Okay.
this is for all the participants. The head node for each of them is up currently.
Okay, nice.
So we have cluster 1, cluster 2,
Yeah,
for
I
each
see.
of them. That's each of the server. So each of the server should be able to pixel boot.
Okay,
But
cool.
like I said the other time, they have a single DHCP server that is serving them the same IP. That is what we could just do ourselves.
It's okay.
So what I want you to do now is to use the first one to see if you can use that to achieve the goal we need to achieve. So you can
So this
click on
one.
the console. Or probably you can open it from the web also.
Okay. How do I SSH to this one?
Yeah, that's why I asked for your IP, so you can SSH into it. That's the IP there, 102.67.38.51.
Okay, let me
You
try.
can see the IP there.
Yeah, I
Minimize.
see. Or maybe I need to
Have,
specify the port.
have you sent your IP?
I need to reach this IP? Please tell me once it's okay. I need to try to reach this IP exactly over SSH.
Please, just 2 minutes. I'm just trying to allow it through the firewall to allow your IP.
Yeah, no problem.
Again, try it now.
Yeah. And maybe it's because I'm not on the head node, but on the management node one. The password is the same?
The password are not the same. I sent the password to you.
because I tried the password, it's not working. Let me update it. Can I show it on the screen, the password, I mean? It's okay for you?
Hold on, let me check again. Don't
Yeah.
show it. The O is 0.
Okay, let me check.
The O in the password is 0.
Okay. Try again. Thanks a lot. I mean, cool. So I have generator. Okay, perfect.
Let me update on what I was trying to do.
I think I am in someone VM because someone already did things here. Is it okay if I proceed inside this VM? I think I took someone VM.
Please come again.
I mean, I think since, for example, this folder already exists, it probably means that I am in
Yes,
demo.
I created that. I was trying to mount the iOS before I had an emergency call.
Okay,
So,
no problem.
and I was having a little bit of challenge in doing that. So probably
Okay,
we can start afresh.
okay. I don't have the ISO in the root, however. You see, I don't have the ISO.
Yeah, that's where some little bit of confusion. I was a little bit confused. The ISO is already mounted in the C drive of the virtual machine.
Yep.
Sorry, on the Proxmox itself. So are
Okay.
we to upload the image into that file, or we can mount it directly from
It's
the...
in the CD-ROM, right?
Yes.
Enough. That's enough. Perfect. Then that's perfect. So you have to use in the here you have to use method. Where is it? Here, it's method 3 to mount the DVD, the CD-ROM directly. Okay. For student, you have to use method 3. Okay, when you want to mount the ISO. Okay, so let me mount the ISO directly in the OS folder. That's perfect. Perfect. File loading. Hang on. Yeah, okay. Okay, that's cool. So let me show you how to do this. Okay, let's start. I will increase the font a bit. Okay, can you read everything now?
Yes.
Okay.
Is it possible it's more than more than this? To
Yeah, of
zoom
course.
a little bit beyond this. Yeah.
Yeah, no problem. 2020 should be enough. This way?
Can we see from the back?
You don't see from the back? Okay, I will do that. This way is better?
Better.
Okay, cool. So let's proceed. Okay, so the idea is the following. First, we have to ensure the firewall is stopped and disabled, because for this training, it would be a pain to handle the firewall, so you just ensure it is stopped, okay? So that's the first part here. We set host name, so Odin cluster localhost. I see here it was already done, but you can check using host name CTL, and it will show you what is the current host name. By the way, when you set a host name, when you set the full host name, it will just grab the first name before the first dot, okay? This is the domain name, and this is the host name of the host. Okay, so now I want, you see here I have two interfaces, ENS 18. This is the one I am using to SSH inside the system, so I don't want to touch it. I am going to use ENS 19, okay? So to use this one, I'm going to set an IP on this one. So let's use NMCLI. So you can use NMCLI show. Show on, I say control, sorry. Show to see the current connection available. So right now I want to work on ENS, this one. Okay. And since I am user 2, I am user 0 for the management here. Okay, I am user 0. So I will just use the same IP than inside the TP, the practical session. Okay. So I set the IP on the interface. Then I just set, okay, now this interface is static, and I want you to start it. So nmcli on up, yes, and it says, okay, now it's activated. So you can see now if I do an IPA, I have the IP on this interface. Okay, I can also show, and I can ask to see all the parameters of the interface. And what is interesting for us is IP4 parameters. You can see here, this is my IP address with the prefix, the subnet. I don't have a gateway, I don't have root, I don't have anything, I don't care for this particular session. Okay, so now I have an IP. The next step to configure the repositories. So it was already done. We removed the CentOS default repositories because by default in etc yum-repo.d you will have the CentOS default repositories that will grab over the net, the internet repositories. We don't want to do that right now for the training part. So we just,
Hello, Bernard.
yeah, this way.
The participant said you are a little bit too fast.
Yeah, okay, sorry, no problem. I will slow down. So, okay. So right now we have our management node, okay, with the IP set.
I'm so sorry.
Yeah, it's okay.
Just
It's okay.
want to be sure that every participant is actually following what you are doing, and not only few people that have. So let me just find out from everyone if they really understand what you are doing.
Yeah, okay.
Yeah, please. Do we get what is currently doing? You have a question?
Mm-hmm.
No, don't do any. Don't implement anything yet on your virtual machine. Just watch what it's doing. Don't do anything. Just follow.
I presume he's still. Okay. I presume he's still. Or maybe interference. Okay. I presume he's still prepping the environment. Oh, then I'm not getting it. What I assumed he was doing is entering to our environment. Uh-huh. Has started the setup already? Oh, then I'm not getting it.
Okay. The idea here is that your environment is here. Okay. Everything is here, ready to be used. And what Bola asked me, if I understood correctly, is to use one of your VM to show you step by step how I do to do the practical session. So after that, you can use your time for this weekend, if I understand correctly, to redo everything asynchronously. So you have time to check everything, understand everything, etc. So today, for what I understand, you want me to show you step by step what I do, so you can ask me question directly, and then during the weekend you can redo everything on your side and practice. Is it what you wanted? I'm sorry, I don't hear you if you try to speak to me.
Okay. Hello?
Yes.
He's muted.
You can continue.
Okay, is it okay for everyone?
Just to be ensured that everyone is carried along. So
Okay.
you can also do it a little bit slow and not too fast.
Okay, I will.
And some won't mind if you can do an overview of what you have done again so that they can catch up.
Yeah, okay.
If you don't mind, thank you.
Give me a few seconds. Let me come back. Where is it? Where is it? Here. Yes, this part. Okay, so right now I am here. If you remember, this morning, I am setting up. We have the operating system already available on our management node. I am configuring the basic repository. Okay, but the first time I need to do it manually because I don't have the HTTP server. And to install the HTTP server, I need the repository. Okay, so the first step here is to, where is it? Sorry, time to get. Okay, the first time here we are mounting the DVD, the ISO, into this folder. Okay, it will be a permanent folder that when we have the HTML server available, it will be the final repository. But right now we don't have any HTTP server available. So we mount the ISO of the CentOS. The ISO contains all the packages. It's a big ISO. Okay, it contains all the packages, and we mount it here. Okay, and now we are going to create a repository file. So we put it in etc yum.repo.d. So it explains the system where to look for packages. And we will say, okay, we want to create two repositories, one called base OS. Okay, and the file are here. Remember, we mounted the var www.html repository CentOS 8. Honestly, this is just for cosmetic. We could have mounted anywhere. It's just for us to organize things, okay? We recreated this kind of folder. So we say, okay, grab the first part of your packages here, and then grab the second part of your packages here. Because in the ISO, if we go into this folder exactly, here, this is the CentOS ISO content. You have two repositories available, base OS and application stream. Remember this morning we spoke about that base OS are just plain packages, very simple ones. And the application streams are packages that allows to you to choose between a specific version or another of a software. Okay, so we need to bind to tell the system where to look for these packages. And inside each, for example, if I go in base OS, you have two folders, repo data. The system will look for the repo data. The repo data contains some kind of database that lists all the packages available inside this repository. And inside the package folder, we have all the packages, everything available to be installed on the system. So just after that, for example, we are going to install HTTP server, and HTTP is an application stream, for example. So we need to go back. You see, we are going to install HTTPD. So this is, for example, the HTTP server, this one, the blue one. This is the package we are going to install just after that. So here right now, we indicate to the system, here are my repository. Here is where you can grab the packages. Okay. So we created this file. Sorry. And we have the packages listed here. So if I do a DNF is a tool to manipulate packages, to install, remove, update, etc. So I do a clean all to reset the configuration of DNS because it has some kind of cache. So you have to be careful when you change something in the repository. You need to DNF clean off first to force the tool to update its configuration. So I do a DNF clean all and then DNF update. And you can see it found the repositories we created. Application stream, base OS and application stream. So now we are able to install packages. And the first thing we want to do is to install the HTTP server. Okay, so here, just go down. We will do a DNF install HTTPD. -y just validates. I will show you. I will just remove it. So DNF install HTTPD. System says, okay, I can install it. I will install this one. But to install it, I also need to install all of these packages as dependencies. Okay, these are needed packages to run this one. So I say, okay, no problem. Yes, install them. It will install the packages. So if we do now an RPM minus QA, so this lists all the RPM available on the system installed. HTTPD, you can see that, well, oh, sorry, HTTP. You can see that now we have our HTTPD package installed on the system. Okay, you can remember, you can note this small command, it's very useful, RPM minus QA. It will list all the RPM installed, all the packages installed on the system. So we have a lot of them, and you can filter using grep. For example, HTTP. You can see everything that match with HTTP. Okay. So we have installed our HTTP server, but it's not running. For example, I will create a file, hello, and I put that in var value HTTP in hello.html. Okay. So I have this HTML file. Well, this file. Okay, we don't care. It's not an HTML. Anyway, if I try to, sorry, I need to install a small tool to show you that. So if I tried to download it, wget HTTP, my IP, remember, and I want to grab hello.html, works. Ah, okay. How did it work? That's a good question. Maybe we have another IP. But anyway, so now we want to start the HTTPD server. Okay, this one, so we can grab packages over the web. Okay, so we do an systemctl start HTTPD. It means I want to start the HTTPD service. What's going on? Wait, why? Oh, someone must have already did this on the node before I did. Anyway, let's remove it. So I start the HTTP server this way, and I can check the status. The system say, okay, it is running. So now you can download file from your own HTTP server. Okay. Also, you want to enable it. Enable it means I want it to start when the system boots. It will create some kind of system link. So now, when my system reboot or just start boot, the HTTP server will start automatically at boot. Okay. So now we have our HTTP server. But for everything to be clean, we want now to have the final configuration. So we will update the file we created before that was targeting a file for the repository, remember? And now we're going to use the HTTP to grab the repository because all the nodes of the network will use HTTP. So our management node should also use HTTP. So we will update the file we created before. This one, and we remove everything and put the new content. Okay, so we say, okay, now I want to download my packages directly from HTTP. Hit save. As again, I change my configuration, so I force DNF to be clean. And if I do a DNF update again, you can see now it's using the network to grab everything. So for example, you see my IP. If I put it down, if I shut down my interface, LMCLE, down NS, this one. So I don't have the IP anymore. If I do a dnf clean all dnf update, it will fail to grab the repository. It's failing because we don't have the network. So it is a proof that now we are using the network to grab the RPM, the packages. Okay, let's stop it. It's no use. So I am putting back my Ethernet connection here. And now I can DNF update, no problem. So now we have the repositories available. We can install repositories. Okay. Next step is to do the DHCP part. Blah blah blah. Yeah, it's interesting also to grab to grab a cluster shell. Okay, so first you need to install wget. Wget is a tool to download file from HTTP. Okay, it's kind of a client, and we need to install few RPM to simplify our life. For example, we want to install cluster shell. Cluster shell is a way to spread command over multiple hosts at the same time. When you want to do I don't know, a simple command on all nodes at the same time, you want to do that. You want to use cluster shell. So we are going to create our own repository this time. Okay, we are not using the repository from the ISO. We will create our own repository. So let's create the folder. Okay, and let's download. I don't know if I have access to the web. Yes, I have. Okay. So right now I downloaded, I use wget, and I downloaded an RPM package from EPEL. EPEL are the Fedora extra packages, and you will use them a lot on the CentOS, okay? Because CentOS lack a lot of packages. So I said, okay, I want you to grab this package from the net, and I want you to put it here. So in the folder I just created. So if I take a look in this folder, now I have my package available. I will also download this package because I know it's a dependency for the first one. And again, now I have my two packages. Okay. Now I have my package, but the system cannot use them. I need to create a repository. To do that, I will use the create repo command. So let's install the tool. Okay, so now I have the tool installed on the system, the create repo, and I will ask to create a repository in the folder, you remember, with my two RPM. Okay, create repo in this repository. Done. And now in my repo, I have the repo data that contains the database of my custom repository. Okay, but that's not enough, because if I do a DNF update, sorry, DNF repo list to list the repositories on the system, I still don't have it because I didn't created the repository file. Remember, we listed the repository in the system. So again, we'll create a file in etc yum repo.d extra repo. Okay, so let's create this file and put inside this. So it means I want to create a new repository called extra with this URL. So again, it's exactly like we did for our base OS on application stream, but now we want to use this extra repository we created. Okay, so I created this way, DNF clean all, DNF update. And now you can see we have a third repository on the system. So we can install cluster shell, the package we just grabbed. It was here. See? As simple as that. So cluster shell is a very interesting command. We will use it later. So now that we have all of this, we don't care about anything else. We are going to install the DHCP server. Okay, so we need to install the DHCP package. Now we have the repository, we can do it. So let's install it. Okay, and we will configure it. So this is the tricky part. Here. We are going to edit the configuration file of the DHCP. This file is etc dhcp dhcpt.conf. Okay. In this file, we will set multiple things. So let me show you. Let's remove the one already in place. We will backup it. And I will explain the content. Just copy paste everything. Okay, how it works. So we are going to create an authoritative DHCP, means this is the one that is handling our network. Here, we explain the system, because when the node is booting, remember we have seen that here, when the node is booting, it will send some kind of discover to the DHCP server. Okay, the DHCP will reply with an offer, and during the request, the node will send to the server some kind of data, okay, about its status. Not only the MAC address, but also what is my architecture. Do I boot with an UEFI by system, or do I boot with a legacy system, etc., etc. On all of this, we have to take them into account into our configuration. For example, if you boot with a BIOS, a simple BIOS, we call it legacy, we are going to use, you will understand the file name later when we build the RAM, but we are going to provide a specific file for that. If we use UEFI, we are going to provide other file, etc. So this part is generic. And it explains, it says to the system, if you boot with this kind of architecture, use this file. Then we create our network. So we define a subnet. Here we remember we are going to use this network. So I want to use this subnet. I can create a range for the unknown node. So here I will, since we are going to use a shared network, I will comment this one. We don't want to, I would say, have a DHCP that do nasty stuff. I set the domain name, the domain server. It's for my DNS. I can bind to a DNS. Well, all of the other elements, just you have to read the documentation. It's not very interesting, but the default list time is how much time a node can keep its address before asking a new one. So for example, when you do the installation of a cluster, you should use very aggressive default list time on max list time. Okay, it's a very small one, because if you want to change something in the configuration, you want it to be taken into account quickly. Once the cluster is in production, you can increase this to a few hours. Okay, these are in second. Then the next server, it means where the node is going to grab the file here, listed here. Okay, we will see that just later in the PXE part, so don't focus on that. Focus here on this part. We are listing all the nodes of the network. Each node with the name of the node, okay, option host name, the fixed address we want to set on it, and the MAC address. Okay, so I'm pretty sure here in the interface, if I have my client node here, I should be able in the hardware part, network here. Here is my MAC address. You see it? So this is the MAC address of the interface, the main interface of my client node. I'm going to use that. Okay, so here in my example, so since we only have two nodes, available. That's more than enough. We remove Tor on Heimdall and we keep Valkyrie 1 on Valkyrie 2. And here I will report the MAC address I see above. So 468F EC FE CC 1A. Okay, so this is the MAC address of my interface. Just checking I did not do any mistake. No, I'm okay. I want this one to have this IP. Same for the second node. Let's take the MAC address and report it in our DHCP. E5 6E C9 45 60. Okay, so we have our two nodes. Just checking I didn't do any mistake. Nice, perfect. So we have our two nodes registered, okay, into our DHCP. And that's all for the DHCP. So let's start it. The DHCP started. We can check what's going on. I want to check what's going on for the DHCP. And we can see that it's started, blah, blah, blah. And it's okay. It just started. Everything is okay. You can see that, well, we already discovered a lot. Well, it's because we are on a shared network. So we are already having a lot of node trying to get an IP. Okay, but our DHCP don't answer to them because these MAC addresses are not into our file, our configuration file. Okay, this is also why I commented this line, and I think I will comment it right now here because we are going to have troubles later if I don't do that. This one. So keep it commented, okay? Nice. Okay, so we have configured our DHCP. Okay, so the DHCP is this one, okay, this element, and we have done the configuration. Now we need to configure the TFTP server. We are going to use the Facebook TFTP. There already is a TFTP server available in the CentOS. Okay, it's called TFTP, but it's absolutely not designed to handle very big cluster, and you will quickly have issues with it. So we will use, well, we don't need to set up the DNS right now. We'll do it later. Let's focus on the PXE. Okay, we will come back to the DNS and everything else. So we are going to create the PXE stack, and we are going to do the Facebook TFTP module. So we need to grab a few things over the web. So just copy paste it. Don't care about. It's okay. So we are installing Git. Okay, Git is a tool to manage code or things like this, to versionize code. And I want to clone the Facebook Git into my system here. So wait for it. Then we will create a package with that, okay? So you just have to follow what I created here. It's quite simple. We ask to create a package for it because the guy from Facebook already handled all of this. And we are creating a package with RPM build. So let's wait. And well, you just have to copy paste. It's not very interesting. You can take the time later to understand what I did here, but it's not very interesting right now. Then let's not focus on this part. What is interesting here is you can see that it created the package for us. The package is here. Okay. Then I want to create a custom TFTP server. So I will do it again. You can take time later to understand what I did. It's not interesting right now, so I will move on this part quickly because it's absolutely not interesting for you to see that. You can take time later for this part. Give me a few seconds. I am following the practical session. This is a spec file here. The spec file defines how to create a package. Okay, so when we do an RPM build, system is going to look for the spec file and create the package according to that. Okay, so we define a custom spec file here, and then we just create our package. So now we have all the RPM we need for the Facebook TFTP part, and we are going to copy, remember, both package into our extra repository. Remember the one we created before. Do not hesitate to interrupt me if you want to ask question, okay? So we copy them. If we take a look now, we have them here, along cluster shell and Python 3 cluster shell. We now have the two RPM we created. So we need to update our repository, then ensure DNF is up to date, and we can now install it. So we created manually our Facebook TFTP server. Because Facebook do not provide an already ready-to-use package, so you have to create it yourself. But it's worth it. The system they provide is very interesting. Okay, so now if we take a look here, we have our TFTP server ready. So we have DHCP, HTTP, TFTP server. We are ready to deploy things, but we miss one important element. We don't have what is called an IPXE ROM ready to be used. Okay, because if we want to be able to deploy other nodes, we need them to boot with an IPXE ROM. An IPXE ROM is kind of a very, very, very tiny, small operating system that starts over, that is spread over the network by your system on the remote node, and that allows you to initiate, to download the kernel, to initiate everything, okay, remotely. We need to create it. Okay, it's what is sent in the schema. Where is it? Here, it's this part, the green file. Here we have seen it.
Hello, Binoy.
Hello?
What was that you said is necessary to start the remote machine? Very tiny little.
Okay, let me
What?
show you. I will take one of my VM to show you that. So here are my VM, okay? I will configure it to boot over the network at first boot, and I start it. When a system is booting over the network, let's pause it. Okay. When a system is booting over the network, the BIOS is going to load some kind of ROM from your network card, okay? It's provided by the manufacturer of your network card. Here, for example, in my virtual network card, there is a small IPXE ROM. Here, it's this part, booting, okay? And this small IPXE ROM, this kind of small operating system, very, very small, few kilobytes, okay, is enough to be able to exchange with the DHCP server to get an IP and to initiate the deployment of your operating system. Because right now, when your node is booting, you don't have the Linux kernel locally. Okay, the Linux kernel is on your management node. Okay, here. My node is booting, but my kernel is not here. I need to be able to communicate on the network. And this is the task of this very small, tiny ROM, this very small, tiny operating system. You see what I mean? It will initiate at the very beginning. It's already embedded. It's already inside your server. It will initiate, and it will allow you to communicate with your management node, to load the kernel, etc., etc. You see what I mean? So this is this part. But, and that is the tricky part. You cannot rely on the one provided by the manufacturers. That's why we are going to create a new one. Let me explain. For example, here, it's a very good example with the VirtualBox software. Okay, this software I am using right now. You can see that in the IPC ROM they provide, I have these features available: DNS, TFTP, HTTP, PXE, PXE-X, and menu. For example, here I don't have the bzip2 available. The bzip2 is a library that allows to uncompress the Linux kernel at boot. I don't have it. So for example, with this virtual machine, I cannot boot the Linux kernel. It's useless. That's why we need to rebuild a new one. Okay, that's why we are going to do that just right now, because we want to be sure whatever the manufacturer we have, whatever the Ethernet card we have on the other side, I want to have the full control. So I will create a new ROM, a new IPC ROM that will automatically, at boot, be exchanged over the network and take the lead on the remote system. Okay, and this very tiny ROM, the tiny operating system, will be my way to load the Linux kernel, load file, and start the deployment. I will show you that. It's very interesting. Okay. Let's create it, and I will show you that. So to create our custom ROM, did I answer your question? Is it okay, at least?
Yeah, thank you.
Okay. Okay, so I need to install these packages to be able to build the ROM. You see that here we are going to do a group install. Sometimes you want to install a huge amount of package on Red Hat on CentOS already provided group. So we want to develop the group install development tool, okay, to install all of these packages. So let's do it. Let's wait. Oh, you have a very good infrastructure, Bola. It's fast. So let's wait a bit. Then we will install a small file also called xzdevel, okay, because we need this file to build the ROM. Let's wait, it should be faster after. This one is the big one, it should be faster. Okay. Let's install this part.
Hello, Benoit.
Hello.
Yes. The tool that you are installing, where the package are coming from? Is it the internal repository or an online repository?
Everything is internal. If you take a look here, we just have these repositories and all of them are defined here,
Okay.
and everything is internal.
Ok. Donc c'est sur la
We,
machine.
we are just using the ISO from the CentOS.
Okay. Is within the ISO.
Yeah.
Okay. Thank you.
Yeah, exactly. That's why I asked for the specific ISO called CentOS everything, because you have everything. You have everything
Okay.
inside.
Okay.
So it's a big one, but at least you don't have to care. Okay, so we are going to create a PXE ROM. Okay, so we are going to create a new IPXE ROM like this one, like the one booting here in my virtual machine. But we are going to create a nice one, the one we can manipulate. Okay. So IPXE again is an open source stuff. So let's clone it on our system. So this one, we are going to grab the sources from the web. So it's a big one. It can take some time. Whoa, you have a very good internet connection. Cool. And we want our, well, that's the interesting part. When you boot over PXE, you have multiple ways to do that. There are a lot of ways. You can use syslinux, you can use shim.uefi. There are multiple ways. The best way I found is to use IPXE with an embed script. That's what we are going to do. So simply put, the node will boot over DHCP. The DHCP will say, okay, here is your IP. Now you have to download this file. The node say, okay, I download it and I execute it. This is our ROM, the stuff we are going to build right now. And once the remote node is executing our file, we have the control of it. That's what we are going to create, okay? So we are going to create a ROM with a script inside. So I created this so you can see it booting on the screen, okay? It's important. So let me show you what's going on. For example, here, you will see that booting on the screen. This big stuff, so you know that your system is booting. Also interesting, you see the features I have now? DNS, HTTP, but I also have ISCSI, TFTP on my BZ image. So I am able to uncompress the Linux kernel now. You see, because I pushed my own ROM inside the system. That's what is important, okay? So let's create the script. I will explain the script, how it works. So basically, the script we put inside the ROM itself is the following. We define it's an IPXE script. It's important, don't forget this one. We put some kind of nice echo so we see something on the console. It's important. If you can put everything you want, it's just to see something. It's important. So you can visualize it. Then I am asking the system to grab a new IP, because when my new ROM is executing, the one on the system, when my new ROM is executing, I want it to grab a new IP. Then I will display what are my network parameters. And I say, okay, now I want you to chain and get this file in HTTP from next server. Remember the next server parameter. It was set here in the DHCP configuration. You remember this one? It was set here. So the IPXE ROM will exchange here with the DHCP and grab a lot of parameters, especially the next server. It will grab this one. So the IPXE ROM will use the variable provided by the DHCP to boot. So you can manipulate it. That's what is interesting. Okay. So let me show you live what's going on. I think it's interesting. I have my management node here. I have my client node here. Okay, I will reset it. Sorry, again, reset. Okay, pause. And I want to show you what's really inside. So here in this first shell, I put it here. I am watching the HTTP server logs. Okay, so the HTTP server is going to talk what is going on. Here, I want to watch the DHCP server and the Facebook server. FTP. What? Oh, yes. It's very big, not cool. Okay, at least we see them. So right now here I have my HTTP server from the management node, and here I have my DHCP on Facebook TFTP server. Okay, and I am booting a client node. Let's wait a bit. So what happened? The node sent a discover. I am 08. So this is my MAC address. Okay. And the DHCP here just got the discover. It received it. So it was registered. The DHCP offer this address to this MAC because this MAC address is already registered in our configuration. So the DHCP said, okay, here is your IP. As we said, there is a second negotiation. Another one, the system is, okay, again, I am this one, can I have an IP? Yes, your IP is here. Okay, so now I am still the client, I request this IP for this MAC address. Can you validate it? And the DHCP server said, acknowledged. I agree, you are this one, and you have this IP. That's all for the DHCP exchange. Then, since in our configuration, we asked for the system to download our custom ROM, we have our Facebook TFTP server saying, hey, I have a node asking for this file. Okay, remember? Here, we said if the system is a BIOS, a legacy, I wanted to grab this file. This file is the ROM, is the IPXE ROM we are going to build. You remember the stuff with the script I just shown you before with the Batman logo. Okay, so the node booted, and since it matched this, it asked to the TFTP server, I want now to download this file. So the Facebook TFTP server just received this request and say, okay, I got this IP asking for this one. So I send it to it. That's all. Action requested, acknowledged, sent, finished. Blah, blah, blah. And it's finished. And then here's the node started our new ROM locally. And this new ROM has the script we are designing. Where is it? Here. The one we are writing here. Okay, the one we created. So as you can see, now it will again after the logo, the Batman stuff here. Now it will sleep for a second, then grab a new IP, then display the configuration on chain. Chain, you will see it means I want you to continue with this script. So now we are able to execute script on the remote node because the node will automatically look for that. The next server, then boot.ipxe. Don't worry, when you manipulate things, you will bring all together. I know it's a lot of stuff to handle right now. Don't worry. Okay? So if I let my system continue here, I continue to watch my DHCP server. You will see it will request again the IP as we described here. Oh, look, I am asking for an IP. And it display everything as we have said here. Okay. And then, as we said, it's going to chain to boot.ipxe, etc., etc. Okay. You will create the boot.ipxe file. We will do that, etc. But at least we are able to have a node, the remote node, doing what we want. We manipulate it now. And that's what is important. Okay. So let's finish with our IPXE ROM. I will close all of that to not saturate the screen. Okay. So I am saving this file. Blah, blah, blah. Okay. And we are now creating, so I tried to explain everything here. And now we are going to build the ROM. Okay. So we need to build two versions of the ROM, the UEFI one and the only one. Okay. Why? Because sometimes you will face manufacturers that provide UEFI compatible system, and sometimes they will provide legacy compatible system. So you have to have both of them, in fact, to be sure you can boot anything. So let's do that. It should be fast. It's not this one. Where is it? Here. So it's going to build the ROM. It should be quite fast because the VMR seems to be performant. So what I want you to understand here is that we try to create something that will work with any kind of hardware. Okay, using that, you're nearly sure to be able to boot anything. So that's what I want. That's what we are doing, everything manually. We want to be able to boot anything, whatever the manufacturer. It can be HP, it can be Dell. We don't care. We want to be able to manipulate anything. So let's wait. It's not very long. It should be fast. Okay, finished. We have the file. Now we build the legacy one.
Hello, Benoit.
Hello.
Yeah, in which directory are you building what you are doing?
Here, right now,
Yes. Which directory? Can you?
in each one here,
Okay.
I'm doing both of
No,
them.
I see that you just go to CRC.
Yeah,
Okay. Yeah, that directory. Where is it from? You can PWD to show us.
yeah, of course.
Thank you.
I'm here.
Okay.
I created it before here. Then
Okay.
when I clone the IPXE stuff, it created the SRC directory.
Okay. Thank you.
Okay, you're welcome. Yeah, I can go a bit faster sometime. Don't hesitate to slow me. Okay, so now we have our file, but it's not in the correct folder, okay, because we cannot grab them. So we are going to create this folder, it's for the Facebook TFTP server, the default one, okay? Because we defined it, where is it? Blah, blah, blah. We defined it here. We said to the Facebook TFTP server service file, I want you to use as root this folder, okay? Because this is a standard one. We don't want something weird. This is a standard folder. Okay, when we created the Facebook TFTP server previously, we configured it to use this folder as default. So now, blah, 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 where is it? We are going to put the two files we created into this folder. Okay. And now, here, if we have a look, the two files are here. So let's start and enable the TFTP server. So we are ready to boot our CApIC-ACE. So now, remember, we have everything ready, but we don't have this file. We still haven't created it. So when the node will boot, so you will see all of that, and it will fail here. Let's try to boot one node right now. Let's stop here and try to boot our client one. I like this system. It's very nice. So you see, it's booting, blah, blah, blah. Oh, see, it's working. We have it. It will ask for an IP, and it will fail later because we didn't create the boot.ipc file. I like this stuff. Procs, mocks, I will I need to investigate it. It's very cool. I like it. Okay, anyway. So you see now that we are missing this file, boot.ipc. Okay, so our node are booting. Everything is okay, but we don't have this file. So let's create it. Okay, so the node communicated with our management node here. It booted, but we don't have the IPC file needed. Well, we can do something fun, for example. Okay, something like this, and check it works. Let's reboot it. You see, it worked. We have the message we just wrote. Stop here, please. Okay, so we are now able to manipulate the node remotely at boot. This is what we wanted to achieve. We cannot do everything we want with the node. So we can now bootstrap the operating system. And you can see that I didn't know the environment from Bola, for example. I didn't know how it was working, but using this generic way to do it just works. Every time it works, it's magic, it's cool. Okay, so it's very interesting to do things this way. Okay, so now let's go again here. Blah, blah, blah. So the CApIC-ACE chain. So now we are able to load CApIC-ACE script from our server. So there are multiple ways to handle the things. You can do whatever you want. My recommendation is to do it this way. You create a file boot.ipc that say to the node, now you will use your host name to target your dedicated file. Okay, so the node will boot, grab the boot.ipc file, then when they will grab this file, they will execute it. And in this script, in this IPXE script, the IPXE script will say, no, you will chain again. So you will again load a new script, but you will use your host name, the host name provided by the DHCP server, as the path to the file. So you can create one file per node. Okay, but doing that is boring. You don't want to have one file per node. It's kind of boring. So this file will just be a link, a system link, to a one that will be shared by all the members of our group. You see what I mean? So for example, I have my storage group or my compute node group. I will create a specific file for it, and then I will create a symbolic link of all my nodes to this group. So I can manipulate things. That's what we want to do, okay? So right now, blah, blah, blah. So I will edit my file again. So it will load this, echo chaining to node dedicated file, and try to grab the node file, okay? We will now create the final boot file, the one that is going to load the kernel and initiate the boot. So this is this file, okay? So we are going to load the kernel. So here you say, I want to load this kernel. The kernel is here. So it's from the ISO, the CentOS ISO we mounted. It's just near the repositories, if you remember. We mounted the ISO here. And inside the ISO, there is a folder called image. And you have PXE-boot inside. And in the PXE-boot folder, you have a kernel ready to be used and an init-ramfs, init-rd image ready to be used. So we are going to use both of them directly from the ISO, nothing more. So we say to the system, I want to boot the kernel with this kernel. This is the path to the kernel. You have to download it to it. It will download it from the network. I want to use this init-ramfs. It is described just above here. I want you to use these repositories, okay, as source to boot everything, because it will need repositories to boot. And I want you to use this automated file. We are going to create this just after that, okay? The automated file described to the node how to be installed automatically, in fact. Okay, you are going to say, I want you to install these packages, I want you to configure this, etc., etc., okay? So let's do that. Let's create a file. So this time, since we have only compute node, well, we don't really care. Okay, let's create exactly what is written in the practical session. So we create this file. We take everything here, put it here. Okay, and your file is ready. So here, after that, once it has loaded the kernel, loaded everything, at the end, it will boot. You will say boot. It's a magical word for IPXE, means I have everything. Now you can boot. Okay, so it will load everything into the node memory and start. What? I cannot. Oh, I forgot to create the folder. So now I have my boot.ipxe here, and I have my group IPXE. I need my node IPXE file because here I'm going to use my node IPXE file. So I'm creating the folders. Sorry. You will see the chain just after that opening. Okay. And in the node, I will go in node. I will create a very simple symbolic link. Okay, like this. But I will update it because now it's not Tor, we are going to use Valkyrie, remember? The node, the compute node described. Where is it? Where is it? Here. We are going to deploy Valkyrie 1 on Valkyrie 2. Okay. So this one. Here one. So in fact, my file here with my hostname of the node is just a symbolic link to the other one, the group one. So using this, I can manipulate everything. I can do everything. So it allows me to have a single file for all my nodes, or I can create some specific file for a group of nodes, etc., etc. You can do whatever you want. You can create a specific file for each node. It's up to you, okay? Really up to you. So right now, our node is going to boot. Let's see what happened. This one. Reset. Yes, please. Okay. So you can see we don't have an operating system because, well, let's reset again. I want you to see that. See here, at the very beginning, the system is trying here to boot from disk and there is no operating system available. So it's trying now to boot over PXE. Okay, so it boots over PXE. Let's wait. Oh, let's see the log. Okay, so I see my node booting. Oh, sorry, it was too fast. Let's reset it again. So you can see the log occurring at the same time. Okay, so the node is booting. We see the logo, blah, blah, blah. These are the HTTP log, okay? So let's wait. And you will see, up, it grabs the boot IPX node, then its own node, Valkyrie stuff, blah, 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 which is a link to the node storage. Then it downloaded the kernel, Linux kernel, the initramfs, and it booted. It will fail, okay, because we still haven't created the automated file. Here, look, it's looking for the file and say, hey, I don't find it. Where is the kickstart file? Because remember, here, we created in node groups, we defined this kickstart file, the automated file. And the node is trying to download it, and it's failing to do that. Okay, so let's create this file at the end, and after that, we are going to deploy the operating system. Blah, blah, blah. Here, okay, to create, so as again, the DHCP provides the room, the ROM, we chain to the boot.ipxe, then we chain to the node name ipxe, which is a link to our group file. Okay, simply. Now we need to create the kickstart. The kickstart is a file that describes how the system is going to be installed. This is exactly the content. Well, you define the keyboard, you define the language, the time zone. The time zone is very important, okay? You need to run it. We say we want to reboot after the operating system installation. We set the root password, so I will just show you how to generate it. We configure the network to be DHCP. We configure SE Linux. We configure the firewall, how the partitioning is going to be made. Okay, so we are going here to use auto partitioning, we don't care. We are going to install these packages. Core is a group. When you have an at the beginning, it means it's a group. Okay, so it will install all the core operating system. And here we are going to install our SSH key. So let's go up and let me show you how we do that. So we need to provide the kickstart file. First, because we want to be able to SSH on the node when it's rebooted, we need to generate an SSH key on our management node. So let's generate a new one. We are going to use this algorithm because the RSA algorithm is considered unsafe now. Okay, so we are going to use this one. So let's generate a key. So I want to be here, and I don't want to set a passphrase. Okay, so I have my key now. If I go in root -SSH, my private key is here, my public key is here. I don't know if you are familiar with what is a private key and what is a public key. If not, there is a very interesting page on Wikipedia. It's called asymmetric. I think it's this. It's in French, but there is an English version here. Public key cryptography. You should read this page. It's extremely interesting. Okay. What you have to understand is that when you do an SSH or when you do an HTTPS request somewhere, you are going to use this kind of mechanism. Okay. And it's very interesting. Okay, let's finish with the node deployment. Then we have a break because today I can last longer because my son is not at school. So I can last longer. What I propose you, we finish this part, the deployment, then you can take a break. Okay, and we continue just after. Okay, because I can imagine it's a bit harsh for you. Okay, so we just need the public key. Let's take it somewhere. Okay, so I took a new notepad here and I store it inside. So this is my
Beno?
public. Yes.
Yeah, when would you like for us to take the break?
I'm sorry?
When would you like for us to take the break?
Just after we have deployed the node. It's soon, in 5 minutes it's done.
Okay, 5 minutes time. So how many minutes would you want?
I know it's harsh for you, but is 10 minutes is okay?
We can make it 15.
15. Okay, 15. Let's deal for 15.
No, 5 minutes for him to finish what he's doing.
Okay, so let's finish with the node deployment and you can have a break. I know it's a big, it's a lot. Okay, so I have SSH key here, and also for my kickstart, I need a password for my new operating system. But I cannot put the password, the plain password. It's completely unsecure. So I will generate an SHA 500 password hash. Okay, so we are going to use Python to do that. You can just use this line, I provided it. And I will use the very, very secure password root. Okay. So this is the password you must absolutely not use, but for this topic, I will use that. Okay. So I generate this and I store it in my notepad also. So I have my SSH key and my password. Okay. Which one is it? Here. Okay. Yeah, I know. Okay, so now we are ready to do the kickstart file. So let's create it. I will copy the whole content here and tune it just after that. Okay, blah, 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 up. Okay, so let's first put the root password. Okay, so we are going to use the one we just generated. Where is it? Here. Don't worry, everything is described in this page here. I also added some notes to explain everything. Okay. So we added this, and then we need to put our SSH key, public key here at the end, because we want, during the installation, we create a post installation. So after the operating system is installed, we want to add our SSH public key directly inside the node authorized key. So once we SSH on the node, it will be automatic. Okay. So let's do that. We put our SSH public key, and it's done. And now we can deploy the node. Okay, so let's do it. So you see it failed because it was missing the file. Let's reset it. Just try again to have the log, HTTP log, so you can see what's going on. So yes, I want to reset my VM. Okay, and you will see that now the system is going to be deployed. So it just grabbed the file as before, the kernel, the initramfs. The system is booting, and you will see during the boot, it's going to grab the automated file, the kickstart file. So the kernel is booting here. Let's wait for it to finish. And see, it grabbed the kickstart. So now the system is going to deploy automatically. We don't have anything to do. We just wait. I don't know if I can zoom a bit for you. Yes, I can. So it's partitioning the system right now. Downloading packages. You can see here it's grabbing all the packages it needs. It has finished, and now it will install all the packages on the remote system. So right now, my client VM is installing everything. So you can see the packages installing. So that's all for how to deploy the operating system. Okay, the very basic part on how to deploy an operating system remotely. This is, after a few years, I found it to be the best way to do that. The most, well, it's kind of mix between flexibility and compatibility. So you can do a break now during 15 minutes if you don't have any question.
Go back. Okay. Business now.
If we come back to
Okay.
I will answer.
There are some questions, but I think we should take the break first. So
Yeah, I think.
after the break.
Okay, enjoy the break.
Okay, thank you very much.
You're welcome. We will see
Yes.
just after that.
Okay.
Hello, Benoit.
Yes?
Okay. I know that it's a break time now, but I have a few questions. Should we
Yes.
wait or can I ask you right now?
You can proceed. The sound is not very good, however.
Okay.
But you can proceed. Don't hesitate. You can ask question if you want. I don't hear you anymore if you have a question.
Okay, can you hear me now? Is it better?
Yes, yes.
Okay, we didn't take a look at the high availability case with two management nodes. I know that this is a workshop and we will probably not work on it, but I'd like to know about the installation of the different services, how we should have done it if we are preparing another management node, a second management.
I don't hear you very well. You mean when you have high availability, how to do that with this mechanism, right?
Yes, that's it. If we have to configure a second management node, knowing that the different services we configure are currently on the first one, what would be the configuration of the second management node?
Okay, give me a second. You see my screen, right?
Yes, I can see your screen.
Okay, nice. This system has an high availability, okay? So here we have two nodes, ISMA 1, ISMA 2, okay? And both of them are working together to achieve high availability. We put the PIC-C part, the whole PIC-C stuff into a single group of resources, okay? And this group has a VG, a volume group for the whole var WWHTML. So when you want to achieve simple, I mean, you can do it very complex things, but if you want to achieve simple high availability, you can choose to pack the whole repository on PIC-C stuff together, okay? So you just create a volume group, a shared volume group between both of them. You have to add a virtual IP. So here, this is my virtual IP, okay, resources. And then I have my HTTP and TFTP resources also running in this same group. So with this group alone, I can do everything. The DHCP don't need to be on the same system. It's okay. You can see here it's on this one. On my PIC-C is running here. It's okay because I have the virtual IP. So in my DHCP, I used the virtual IP as the source, the next server on the repository IP.
Okay, okay.
Question?
Yes, I understand.
Okay. All of this assume you have a shared storage between your two nodes. Okay. If you want that, you can emulate one using Linux DRDB. This.
No, let me see. Let me see. Who is the person that asked question? Okay, Koto, go on.
If you don't have a shared storage, you can use this tool. Okay, it's very interesting for high availability.
Okay, thank you.
You're welcome.
Okay, please, you can go for your break. No more questions, please. Both virtual and physical here, please. Yeah, Bernard, please, you can go for your break. There's no more question for now, both virtual and physical.
Okay, just
so
you
that
can
you
see
can
that.
take a little bit of
Okay,
rest.
thanks.
Thank
So
you
you
very
can
much.
the node booted and is ready now. Okay, see you in 10 minutes.
Yeah. Thank you.
You're welcome.